The experiment that couldn't be undone. At first, it looked like progress, a clean result, a breakthrough everyone had been waiting for. But some discoveries do not stay contained. To understand why this one matters today, we have to return to the moment science crossed a quiet line, the line between testing reality and rewriting it. For centuries, experiments were designed to observe, confirm, and step back. Knowledge accumulated, but the world itself remained largely unchanged by the act of knowing. That assumption no longer holds. This experiment began with a simple goal: measure phenomenon more precisely than ever before, eliminate uncertainty, reduce error, reveal the truth hiding beneath statistical noise. The setup was elegant, controlled, and peer-reviewed. Nothing about it suggested danger. Early results were celebrated. The data aligned perfectly. Predictions tightened. Models became sharper. For the first time, scientists believed they were seeing the system as it truly was, stripped of ambiguity. Then something subtle shifted. Repeated trials no longer produced the same baseline. The system behaved differently after each measurement, not randomly, directionally, as if it remembered being observed, adjusted itself, drifted away from its original state. At first, this was blamed on contamination, then on equipment fatigue, then on human error. Each explanation collapsed under scrutiny. The change was real, persistent, and irreversible. This was the first reveal. The experiment was not just measuring the system, it was changing it. And worse, there was no way to reset it. Once observed, the system could not return to its original behavior. Every attempt to study it further pushed it farther from where it began. Knowledge accumulated, but so did alteration. That was the moment unease replaced celebration. Because if observation permanently alters what is observed, then experimentation is no longer neutral. Discovery becomes intervention, and every answer closes a door that can never be reopened. The experiment that couldn't be undone had done more than reveal a truth. It had crossed a boundary, and what waited beyond it was still unclear. As researchers pushed forward, the implications grew heavier. The system's altered state was not temporary. Time did not restore it. Isolation did not stabilize it. Even attempts to simulate its original conditions failed. Something fundamental had shifted. This was not damage in the conventional sense. Nothing was broken. No components were destroyed. The system still functioned, but under a new set of rules. Rules that only existed because the experiment had taken place. This led to a deeper reveal. The experiment had introduced information into the system, not data stored externally, but information embedded within behavior itself. The act of measurement had become part of the system's history, and history, once written, could not be erased. Scientists recognized a disturbing pattern. Each additional measurement amplified the divergence. The more precisely the system was studied, the less it resembled its original state. Accuracy accelerated transformation. This inverted a core assumption of science. Precision was supposed to bring us closer to truth. Instead, it was pushing reality away from where it started. The system was not revealing itself. It was adapting to scrutiny. Debate erupted. Some argued this was a rare anomaly, a special case confined to unusual conditions. Others warned it was a preview, a glimpse of what happens when systems become sensitive to information itself. The conflict sharpened when similar effects appeared elsewhere. Biological systems alter behavior under observation. Algorithms shifted outputs when monitored. Markets changed dynamics when measured too closely. Across domains, the same pattern emerged. Observation left a footprint. Once information entered a system, it could not be removed without consequence. Measurement was not passive. It was an irreversible act. The emotional weight of this realization settled slowly. Science had always relied on repeatability, on the idea that experiments could be reset, rerun, and verified. But here, repeatability itself was impossible. The first measurement changed the conditions for the second. This forced an uncomfortable question. If some experiments cannot be undone, then how many irreversible changes have already been made in the name of understanding? And more unsettling still, how many more are we prepared to make? The conflict reached its breaking point when scientists accepted what the data implied. The system was not malfunctioning. It was responding logically to being known. Once information entered the system, it altered future possibilities. Paths that once existed closed. New ones opened. The landscape of behavior reshaped itself around the fact of observation. What could happen next depended on what had already been measured. This shattered the final illusion of control. Researchers realized they were no longer studying a stable object. They were co-authoring its evolution. Each experiment nudged the system further along a trajectory that could not be reversed. Knowledge was no longer cumulative. It was directional. The emotional tension intensified as parallels surfaced across science. In ecology, measurement changed behavior. In medicine, intervention altered outcomes beyond intention. In technology, monitoring reshaped systems faster than designers could predict. The same pattern repeated. Understanding carried momentum. The more deeply a system was analyzed, the more it reorganized itself in response. Not consciously, structurally, the act of inquiry became a force. This forced a reckoning with responsibility. Scientists could no longer pretend to stand outside the consequences of discovery. Asking a question meant accepting the changes it would trigger. Precision became power, and power demanded restraint. The build-up peaked when researchers acknowledged a limit they could not cross back from. The original state of the system was gone forever. No archive, simulation, or reconstruction could restore it. The past had been overwritten by observation. This was not a failure method. It was a feature of reality. Some systems remember being known, and once they do, innocence is lost. The experiment that couldn't be undone was no longer just a cautionary tale. It was a warning, a reminder that knowledge does not simply reveal the future. It reshapes it. And the most dangerous experiments are not the ones that fail. They are the ones that succeed too well. The climax arrived with a realization that could no longer be avoided. The experiment had crossed a threshold where understanding itself became an irreversible force. What scientists uncovered was not a hidden property of the system, but a rule about interaction. Some systems do not tolerate being known without changing. Information does not sit neutrally inside them. It reorganizes them. Once that process begins, there is no return to the untouched state. This reframed the meaning of discovery. The experiment did not simply uncover truth. It replaced one reality with another. The original condition existed only once, and only until it was observed. Every measurement afterward described a new world, shaped by the act of inquiry. The resolution was not fear, but responsibility. If knowledge alters outcomes, then restraint becomes part of science. Not every question must be asked immediately. Not every measurement should be pushed to its limit. Understanding carries weight, and that weight must be acknowledged before thresholds are crossed. This matters now because modern science increasingly operates on systems that adapt, remember, and respond. Biological networks, learning machines, social systems at scale. In these domains, observation is not neutral. It is formative. The experiment that couldn't be undone revealed a future where progress cannot be separated from consequence, where curiosity reshapes the very thing it seeks to understand. Knowledge is no longer just accumulation. It is commitment, and once made, it cannot be withdrawn. The